Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to vector analysis or vector calculus, and chapter name is the gradient. We have to prove del that is a vector operator r to the power n is equal to n r to the power n minus 2. N minus 2, it is wrong. R minus 2 and r vector. We have to prove this. So first of all, we know r is a modulus of vector r. Vector r, we know that vector r in general xi cap plus yj cap plus z k cap. So small r is equal to, which is a scalar, vector r is equal to xi plus yj plus zk. We know that the modulus of vector r is equal to square root coefficient of I, square root of square root, and in square root coefficient I whole of square, coefficient of j square, and coefficient of k square. On squaring both sides, we can remove this surd. R square is equal to x square plus y square plus z square. This is the relation by which we can find the value which we will use in succeeding steps in finding the this value or proving this value. So first of all, I differentiate this value partially with respect to x first and then y and z. So I write this differentiating partially equation 1 with respect to x. On differentiating r square, we know that this power will go in multiply with r to the power 2 minus 1, because this power reduced by 1, but it is not x. So differentiate r with respect to x partially. On right hand side, x for x, y and z are constant because it is partial differentiation. So differentiate only x square, which is equal to 2x, but differentiation of y square and z square is 0. Now this value becomes 2r dr over del r over del x is equal to 2x. You can cancel out 2 and find the value of del r over del x, which is equal to x upon r. You are seeing that it is in r is here and x is there. It's a cross relation. Similarly, we can write del r over del x by cross relation as y upon r, and also del r over del z is equal to z upon r. Now we will use this value in fourth going steps. We have to now prove del r, and I write only left hand side which we have to prove, and we try to find the right hand side. So first of all, we write the value of del operator, which is I cap del over del x plus j cap del over del y plus k cap del over z del z, and it is and now r to the power n. Now this operator will operate on r to the power n, then it will become I cap del over del x rn plus j cap del over del y rn plus k cap del over del z rn. Now we have to differentiate rn with respect to x partially and y and z respectively. Therefore, I cap on differentiating r to the power n with respect to x partially, this power will go in multiply, and r power of r will reduce by 1, but it is not x, so differentiate r partially with respect to x because it is not x, and I apply here chain rule. Also this calculation apply there. You can also use sigma, only write this term and use sigma. Then if you use sigma, you should not you must not write these terms, but I not use sigma. I repeat this calculation again and again. Then j cap n r to the power n minus 1 del r over del y, same calculation as we done here. K cap n r to the power n minus 1 del r over del z. Now I have already solved this value. I find this value here. So I use these values in these factors, so this becomes, and this is equal to del r to the power n I cap n r to the power n minus 1. This is equal to x upon r and j cap n r to the power n minus 1, and this value is y upon r, also value k cap n r to the power n minus 1 z upon r. Take out common from these terms, we get here n r to the power n minus 1 upon r is common in these terms. We now write the remaining terms, factors and terms in this bracket. After taking this value is common outside from bracket, we get xi cap and plus yj cap plus zk cap. But we know that this value is equal to vector r, so I write this equal to vector r. So and we know that when weights are equal, then on division power must be subtracted from numerator. Here is not written power, degree of r, but we know that if not written it is equal to 1, and on division we know that it's must be with this one must be subtracting from r minus 1, and this value is vector r. We apply formula here, a to the power m upon a to the power n is equal to a to the power m minus n. This is identity which I applied in this, and we get del r to the power n, and gradient of r to the power n equal to n r to the power n minus 1 becomes minus 2 vector r, which was to be proved. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.